we are here for, a very interesting panel discussion. We have some of the best dynamic leaders and visionaries from precast industry. So I will be having a detailed panel discussion on various aspects of precast industry. For that, I would first like to invite Mr. Dhananjay Bhosale, who will be moderating the session. So Dhananjay sir is convener for SEMCON 2021. And we have panelists from all the facets of precast industry. So we have Mr. Vinay Gupta, who is president for ICI. We have Mr. Raj Pillai, who is chief technical officer for JMC Projects. Mr. Yogesh Kajale, who is vice president for BG Shirke. Mr. Anurag Sachan from Fuji Silvertech India. Mr. Hemant Dhonde, who is concrete technology expert. Mr. Mohan Ramnathan, who is veteran of precast. He was to join us, but since he's not keeping well, he won't be joining us today. And apart from that, we have a team from our SEMCON 2021 technical team. We have Suresh Tripathi sir, we have Ravindra Bhosale, and other members also from ICA Pune team will pitch in where required. So all these personalities, all of us know them very well, so they don't need a big introduction. The name itself is enough. So I would request Dhananjay sir to take this ahead. Over to you, sir, Dhananjay sir.
First of all, to start with, I will just present the glimpses of our offline event so that everybody will get summary of what has happened in the offline event because we have just talked about it. So I would like to present something about that, like some of the photographs as sort of memories of that offline event. So I will just share my screen to show those things. I will just share this thing like this event was in collaboration with the supporting organizations to ICI Pune Center was Pune University as well as College of Engineering Pune. So this event was inaugurated by Vice Chancellor of Pune University, Mr. Nitin Karmalkar. And there was a different type of attraction in this COVID period, like it was a physical event which was attended by more than 200 people, and plus there were around 20 stalls for display by different technology providers. And this was the inauguration which Karmalkar sir has done for the stalls. And this is how people enjoyed a lot, spending time interacting with the different technology people. And even the technology presenters, they were also excited to meet people in person and then explain about their products and then have interaction with a lot of industry people. So this was one of the attractions, like we had 20 display stalls, which people visited very frequently and they had a very good interaction with the technology providers. Then again, some of the presentations, I'll just go through that, like Amit has provided a very good presentation there, but somehow since the time period was very tight, like in a day we have to cover 8 sessions, so we couldn't give him much time, so he had to curtail his session. So neither he was satisfied nor the listeners were satisfied. We again kept his presentation in the online event so that he gets sufficient time and everybody can enjoy the his detailed presentation. Then there was a presentation by Dinesh Kumar about comparison of different building standards, like what happens in US, what happens in India. Then there was a presentation by Enric Solsona from Spain about how to keep in control the upfront investment challenges in case of precast project, because whenever a new precast initiative comes, everybody has got some apprehension about the initial investment that goes into that. So he had a lot of insights into that, how to control those things. Then Saurabh Purandare has presented his views on cost-effective design standardization in case of large-scale precast projects. Then we had Antonio Cucciara from Italy about selection of different type of economical precast production methods. And he shared his different experiences at different places, like he was working with precast plants and other places. So he shared all his experiences in that. Then we have presentation from Sanjeev Sharma about selection of right precast systems and right connections. So that was also a quite interesting presentation for everybody to watch. Then there was a presentation from Mr. Eli Bhol of Dubai. He presented about the importance of mechanical splicing using grouted sleeves, and he presented a lot of their overseas projects as well as examples of Indian projects also. Then there was another presentation about fast and efficient erection methods using the latest tower cranes like flat top tower cranes. Normally, they are available nowadays in India also. So that was presented by Javier Militino from Spain. And that was also quite an interesting presentation about because he presented the ways how to lift the PPVC type of elements, even 20 tons, 25 tons capacity, and what type of tower cranes are used, and in which case, what type of tower cranes are efficient. So it was a very nice presentation from his side. Then there was a presentation from Mr. Sid Daher from Malaysia about how to use ready-made precast accessories. Like there are many lifting accessories, many inserts, lifters, and other accessories which can be used in precast elements to have efficient handling of those systems. Then Vaibhav Singhal from Elimatic, he presented about the cost advantage of precast structures in commercial type of structures. Then there was a very good presentation from Sika about effective use of grouts and sealants for precast joints by Pushpam Kumar and Ritesh Singh. There was another presentation from Mr. Vijay Shah about techno-commercial evaluation of precast hollow core partition walls instead of normal AAC blocks or other type of partition systems, how these type of precast hollow core blocks can be used or hollow core panels can be used rather, and their cost effectiveness. Then there was a presentation by Shabbir Lokhandawala about building information modeling, how it helps and what type of intricacies are involved in doing the building information modeling for efficient detailing of precast projects. Another place of attraction was the large open area near the auditorium. So people really enjoyed networking there and having discussions. So many times I found that people were enjoying interacting with each other after a long time because of COVID, and people enjoyed this quite a bit. That's what I wanted to just showcase, like how people enjoyed this event, the offline event part. So this is just to summarize like what happened in the offline event. And there were other presentations, also interesting presentations, and we'll make those recordings available to all the participants so that there will be some definite time in which these recordings will be available that will be communicated to everybody by email later on. So I think we can move on to our panel discussion. So the topic of this panel discussion is mainly about the present status of precast construction in different segments, as well as what is the path forward and what type of future we expect. So to start with, I will start with Mr. Raj Pillai about, sir, what is your opinion on the developments or future of precast technology in residential commercial type of projects?
First and the foremost, thanks to ICI Pune chapter. My relationship with ICI goes deep. I was vice president ICI South way back in 2011 to 2013. And this reminds me sometime in 2012, I had physically attended the SEMCON at the same venue at the Holiday Inn, which was done by ICI Pune chapter. So thanks for taking me back to the memory lane. Thank you for all the office bearers and the functionaries of the ICI, because during these difficult times, to organize a function like itself is a big task. And that too, to pick up a topic like precast and to take it forward, I think very, very good proactive measure for the industry right at the beginning of 2022, because after the last 2 years, we all in the industry look forward that 2022 should be a good year ahead. Coming back to the question, I was fortunate to be in the concrete business for long, and I have seen how the ready mix concrete evolved from 1995, when I was fortunate to start one of the earliest commercial batching plant in Bangalore. So I would say, if we say that the similarity between the emergence of technologies in India, this ready mix concrete always comes to my mind when I try to have a link between this and the technology like precast. So I think we had the same notions back those days, from 95 till 2005, when all kind of questions were asked when it comes to ready mix concrete. And today the ready mix concrete has become like a commodity. So I think my take on precast, and I would not call it precast, I would call it, for all purpose, off-site construction. I think the off-site construction is going to be the norm than the exception. In my view, way forward, and which would happen more sooner than we think, because the way India is poised for large scale construction, I'm a firm believer that all the groundwork which has happened in the last few years would evolve into a large, massive construction surge in India. We need airports, we need houses, we need roads, we need infrastructure, you name it, everything, and we need it. And there is a political will to do that now. So I believe if we have to do it the way the world does it, and to gap the mismatch, of the speed which has not happened, the only way forward would be offsite construction. Now, I would also like to add here that precast is nothing new in our country. We just have to go 1,000 years back, not very far, only 1,000 years back. You look at all those old temples, how beautifully they were done, and they were not done with concrete. They were done in stone masonry. And those joints today, even today, they have stood the test of time, you know. So I think precast is in our DNA. So also considering the fact that during the last 2 years, especially when the lockdown first opened in 2019, we all in the construction industry realized how difficult is our dependence on the labor force. And today, for every construction, the dependency of labor is a big, big question mark. And everyone wants to have a control on that. So if I club all this, what I have said, I see a great future in precast. And I think it has to only go forward. My only word of caution would be is that very soon the time will be there when we have to do it by compulsion, by not choice. So the early we get ready, the early we get prepared, early we remove all these doubts from our mind. See, trust me, none of us, all the panelists over here or the speakers who have spoken for the last 2 days, have invented precast. It's a
Yeah.
proven technology. The world does it. Singapore 99% does it. Just 3 hours flight from here, go to the Middle East, they do it. So it's a proven thing. So my request to everybody would be, remove these doubts from your mind, get ready, because sooner than you think, you have to depend on offsite construction. So that would be my take on this panel discussion at the beginning of it.
Thank you, sir. And my next question would be to Mr. Yogesh Kajale. Sir, what type of standardization in precast components do you see happening in your place, or are you envisaging any usage of ready-made accessories in precast construction so that you can automate your construction processes to maximum extent? So, what is your take on this?
See, per se, the standardization is basically to have the flexibility in manufacturing the element. We
Yeah.
can't think of having a standard set of columns or beams or wall panels or slab panels, because
Yeah.
the precast has to be adaptable to the end user's need. So the plan may change, plan would change. So the technology, rather the manufacturing and handling system should be adaptable to any user's requirement. To do so, instead of going for a fixed mold system, we must have a manufacturing system in such a way that we can manufacture the elements of any size, any shape, just by altering the side panels or maybe by shifting the end plates. So that kind of standardization in terms of manufacturing sets are necessary, not in terms of the element per se. That's what is my view.
Yeah. And what is your take on using ready-made precast accessories? Like, do you see that going to be a major game changer in going forward, like automating the construction processes, or a
The major
customized one is going to be a better solution for you?
the major game changer would be to have the standardized, rather to have the custom tailor-made reinforcement cages manufacturing unit, because that's the
Okay.
biggest challenge. We can speed up the manufacturing process of precasting provided we have that manufacturing sets of reinforcement. So in India, in next 4 5 years of time, we would see a lot of reinforcement cage manufacturing companies also would be ready to supply tailor-made cages.
Okay.
So apart from accessories, this is the major challenge what industry is now facing. We have huge volumes, the construction time is getting reduced. So what is more important is to have the set of reinforcement cage manufacturing units as well, which would support the precast manufacturing facilities. As far as accessories are concerned, it is basically limited to jointing. Those numbers are not to that extent big, but the reinforcement cages is a huge number, is a huge volume. And there in India, no doubt, many precast manufacturers have increased, but the reinforcement is still a bottleneck.
Okay, so my next question would be to Mr. Anurag Sachan. Sir, as you are involved in railways, like you are MD of Railway Dedicated Freight Corridor, can you throw some light on what type of standardization railways has done in precasting, and what is the way forward you feel railways will be having, or any infrastructure projects will have for precast
Yeah,
technology?
first of all, thank you very much, Mr. Bhosale, and thank you, SEMCON, to give me an opportunity to interact with all the great players of precast industry. I'll like to share my experiences working in railway as a civil engineer for almost 37 years. In fact, during my tenure in railways, I have executed large number of projects. Of course, the last project was dedicated freight corridor, which will come a little later, costing almost like 1 lakh crore, which is one of the mega project of Indian Railways. So, but I'm sorry to say that in India, we are doing a lot of mega projects we are executing, but precast is concerned in railways. Precast was limited to only very few pre-stressed concrete girders of 10 meters, 13 meters, and 18 meters span. Besides this, in spite of doing huge volume of work, railway was not using this technology. As far as dedicated freight corridor is concerned, as I told you that this project cost 1 lakh crore, where we are constructing 6,000 kilometers of dedicated freight corridor from Delhi to Mumbai and Jalandhar to Sonnagar in Bihar. But here also in this, we were doing the work with the same conventional method of cast in situ, besides some pre-stressed concrete girders. I always used to think that why we are not using precast technology. And after my retirement last year, I got this great opportunity when you must have heard about Fuji group of companies. There is a group of Japanese companies who have the experience of more than 70 years in precast. They are much, much better than our IS codes. That is what I asked the question from Mr. Amit Bade, that when I started working for precast, we found that our Indian standard codes are not helping precast industry, because if it is a question of cover or question of minimum thickness of any element, they are silent about it. There is no difference between cast in situ and the precast. So anyway, with my vast experience working in a government sector in railways, I could find out some way out. And after joining Fuji, it's a joint venture between Fuji group of companies of Japan and a Silver Tech, which is an Indian company having two plants. One is in Ahmedabad and another is in Aurangabad. So we started doing a lot of work in precast. So in fact, after my joining, we started constructing precast RCC boxes up to 3 meter by 3 meter span. Because if I talk about dedicated freight car road, there are 15,000 bridges to be constructed in 6,000 kilometers. And any linear infrastructure project, construction of structures is a most critical thing. So if you make it precast, if you standardize the sizes like 1.5 by 1.5, 2 by 2, 3 by 3, you can simply cast those box segments in factory conditions, bring it to the site, and you can provide a green construction. So I'm very happy to inform you that we could use these precast boxes, and we are doing side drains, which is these are very high strength concrete, M50 strength, self compacting concrete with Japanese technology. And now one high speed project is coming up from Ahmedabad to Bombay, where noise barrier, because this high speed trains will run at a speed of 350 kilometers per hour. So they need a noise barrier, which is made up of very high strength precast concrete. So we have also made a prototype of this precast noise barrier, as well as cable ducts of M75 strength of concrete, which will be self-compacting concrete. So this is just a beginning. We are at the nascent stage, but I think SEMCON is doing a great job, and this is a very good platform to share our experiences. And we'll be very happy to share what we are doing so that in India, we can provide a very good quality precast construction. Thank you very much.
Okay. So now my next question would be to Mr. Hemant Dhonde, since he is a concrete specialist and he deals more into real-time monitoring of performance of quality of concrete. So can we use any type of sensors which can provide us real-time data of precast concrete elements, like about the strength of those elements or the performance of the concrete? So can you throw some light on that?
Hello, certainly. Thank you, Engineer Bhosale. Thanks for having me here, SEMCON and ICI, and your patron. It's a very relevant question, especially when we are aiming for productivity and quality and high performance material being used day to day in routine precast construction. The most critical part in quality remains as a challenge, and that is availability of competent workforce. Very few workforce is available to monitor, record, and take mitigating actions pertaining to the quality of concrete which we have cast. For this matter, to make it more autonomous and close to Industry 4.0 protocols, nowadays, for the last 40 years, people around the world have been using sensors not only to capture the thermal profile of the concrete, but also to evaluate based on maturity rationality, the strength of that concrete in real time, anywhere, any place in real time, at the palm of your hand, that is on your mobile phone and connected devices. You'll be able to get reliable information related to strength gain and other performance characteristics of the placed concrete. This meters, which are called maturity meters or maturity sensors, are quite costly around the globe. Hence, we started making and manufacturing these meters in Pune at C-Probe Technologies. And my students themselves, they manufacture this and sell this not only in India, but abroad. And what we have found is that these sensors are capable of potentially saving about 10 to 20% of resources, concreting time, as well as bring in the confidence required in concreting work through reliable data on which the engineers can take effective and timely and safe decisions. Therefore, I feel strongly that India is now ready for this affordable, made in India and available pan India meters and sensors to produce quality precast build spaces. With that, I would pinpoint another point here that Amit, during his presentation, pinpointed was to integrate various new technologies together for better precasting jobs. And here, this technology, which is the maturity meter sensors that we have developed indigenously, uses data science, structural health monitoring, Industry 4.0, and can be integrated with building information modeling as well. Most importantly, this method has a potential, proven potential to replace partially or completely the people-driven or human intervention-driven cube test or cylinder test destructive test. Therefore, this comes under the non-destructive test category as prescribed by IS 456, IRC 112, and other Indian codes. Thank you.
Mm. I think Tripathi ji wanted to ask something
Yeah.
about it.
Yeah, Mr.
Sure.
Hemant, tell me, in IS codes, they are prescribed that with certain time only you can open the shuttering. So how do we integrate that? Because if suppose your concrete is gaining strength much earlier than that, then how do we convince the codal people? So these codes do provide in that.
Yes, it's a relevant question because this method is quite new in India, very rarely used. Hence, it is good to know that IS 456 clause 17.8 does
Hmm.
allow you to use maturity method as one of the non-destructive methods to ascertain the performance and strength characteristic of placed concrete.
And how
So
reliable is the
this,
data basically in this?
yes, the method has been globally proven for the last 40 years. Almost 85% precasters in developed countries are using this method, and along with that, they are been using match curing, which is the next step of maturity method, also for the last 20 years. I think we are quite far behind in precasting, adopting this technology in precasting works. Therefore, our company initiated this program to develop an affordable and usable, available technology for precasters as well as the in situ concreting works.
My question for Mr. Sachan is, Mr. Sachan, you are using you told you are using around M75 for your some elements. So with M75, there will be a lot, you have to manage heat of hydration and other things. So how do you manage that? Are you using some type of this technology which Mr. Hemant is telling or something, or in Japan, you have that experience of using this type of things also?
See, this in our factory in Ahmedabad and Aurangabad, we are using self-compacting concrete, which is a little different than our normal concrete, where lime is also mixed and a lot of admixtures are mixed. But somehow, because this is Japanese technology, so it is their trade secret. And in fact, they themselves control the entire batching plant, etc. And we only check the final strength. So we are at the moment we are constructing precast boxes, etc. of M60 strength, but in high speed their requirement for cable ducts, which is a very thin element. So their requirement is M75, and this specification also is made by the Japanese.
Okay.
So we are very confident that since Japanese are working with us, and so we'll be able to do it. One more very important thing I like to mention here, we are doing steam curing, as you are telling that how the hydration, heat of hydration, etc., is taking place. And this steam curing also is a trade secret of Japanese. They decide that what kind of cement you are using, what kind of cement and aggregate we are using, and according to that, they decide the curve, how the steam temperature will go up, for how much time it will be steady, and then how it will go down. So they are really expert in that. We are really very much backward as far as in India. Our knowledge about steam curing, etc., is very limited.
But we are, see, I come from Patil Group. In Patil Group, we are, since you are from railways, we must be understanding that we are having so many precast sleeper plants. We are maintaining that type of standards and doing that, even steam curing is being done. So I think it will not be right to say that, yes, we are much backward, but yes, we are catching up with the world. That's what I would say.
Mr.
Uh,
Tripathi, I just want to say that except concrete sweeper, because concrete sweeper, if you see the overall industry, concrete industry in India, is just a peanut. So that is what I meant to say, that it is
Sorry.
it's very limited, only these concrete sweepers. Yes.
Dhananjay, if you allow me to ask one
Yeah, yeah.
question from Raj sir. Raj sir, you had great experience with Shobha and then the other company in Starworth. You have been doing residential to such a good form, which most of the people are giving examples of it. How has been your experience in standardizations in your project?
Okay, Tripathi ji, good to see you after a long
Yeah.
time. See, I would, before I come to that question, I would take the discussion backward to what Hemant was talking about. I think
Yes.
Hemant was talking about a very, very important subject in precast. And everybody in audience must understand that the success and failure of precast is mainly driven by the quality of the concrete which is made.
Absolutely,
Uh,
sir. Right.
it's simple as that, garbage in, garbage out, quality in, quality out. Now, there are two angles to quality of concrete when we talk about. One is, from the codal provision that, if we are making M75 grade of concrete, we should have 75 MPa at 28 days and etc. But I think there is, in case of precast, there is another angle which where this maturity meters comes into the picture, is that in case of precast, what we need is the what we call as the stripping value. The minimum value the element should achieve, so that it can be taken off the bed. Now, this stripping value is by and large done with the data available, and then you correlate the data that, for example, if I want M40 grade of concrete, and depending on my production cycle and production facility, I need 12 MPa at 12 hours time. Then the challenge with the precaster is to optimize his mix. What is the
Perfect.
optimization you do so that you maintain a balance between your quality and your cost. Now, I remember almost 20 years back when I used to work one of the leading ready mix manufacturer in the world. They used to have a system called QSUM. Now, this QSUM was done using meter, and what they were doing is, in testing the cube strength at the end of the 28 days and then working out the optimization of the mixes, these maturity meters were used to the optimization. So I think what the technology does is that, in case of precast, if you want to get the right precast in place, you also have to use the best practices of the concrete. Like, for example, the batching plants of the precast, because you use concrete even to zero slum, you have to have good mixing capacity of the batching. So I think Hemant has touched upon a very good subject, that if we have to get precast, and I think this is what Mr. Anurag was also talking about. I mean, the Japanese knows very well. I know some of those companies where they know how to play with the heat, because it's all about optimization. It's just that how we maintain a balance between the cost and the quality. Now, coming back to the question Mr. Tripathi asked, yeah, I've been very fortunate to work with two large residential projects, high-end residential project. The Shobha project was done. I mean, the story began sometime in 2011. But before that project, I would also like to say something which is close to my heart, which is, I had an opportunity when I was in Shobha to work on a project which is right behind the Bangalore railway station. It's a 36-story residential building, and I'm talking way back in 2010, 2011, when we decided that can we do a high-end residential project without using any external and internal plastering and grinding. Because trust me, in construction cycle, the plastering and grinding is a nightmare for everybody. So we embarked on this journey, and again I would say, to maintain the balance between the cost and the quality, we went for, in place of self compacting concrete, we went for self dynamic concrete, which is a more toned down version of self compacting concrete, but gives you all the benefit of the self compacting concrete. And of course, good quality practices with the formwork system in terms of line and level, in terms of the training to the workforce. And this building came out so well that not a single millimeter of plastering or grinding was done. By doing this, because I believe if you have to do a quality product, the core and shell should be plaster free. I always say jokingly that if I have the authority to change the construction in India with one rule, just one rule, all the BIS, everything NBCC put together, just one rule. That one rule will be no plastering, because that
Yeah.
sums up everything. You got to
Very,
get your concrete right, you got to get your formwork right, you got to get your construction practices right, everything right. So,
very true.
so I would say that project gave us the confidence that, because I have seen all over the world, you look at the Paris airport, there is no plastering. Absolutely. Best of the buildings in the world have no plastering. We have a building in Bangalore, which was done way back in, I think, in the late 60s or the 70s. Absolutely no plastering. I'll give you, this is because this is my favorite subject. So, Mr. Dhananjay, you have to bear with me.
Yeah.
Uh,
Yeah.
we produce more than close to 350 million tons of cement in our country. And
Mhm.
ladies and gentlemen, to produce 1 ton of cement, you emit close to 1 ton. Now, of course, with efficiency, the cement companies have brought it down to zero point 0.8, almost 1 ton of carbon dioxide into atmosphere. So 350 million tons of cement means almost 300 million tons of carbon dioxide into the atmosphere. You will be
Mhm.
surprised that more than 50 million tons of cement goes only in plastering. And we all know why we do plastering. So
Mhm.
I think, if we get concrete right, like what Hemant was touching upon, and that is where I got excited on concrete, that if we get our concrete right, precast is a logical thing to happen. It's just logical thing to happen if we get our concrete right. So now coming back to the Shobha journey, we wanted to do a project which was close to 10 million square feet. And at that point of time, Shobha was doing only two products. One was super luxury, which was in Bangalore, which would cost around 3.5 crores. And another next is luxury. So 1250 to 300 square feet apartment would cost almost 1 crore. So my chairman said that, keeping in mind the Shobha standards and the philosophy, he says, Raj, can we have a product range which will be cheaper than 1.5 crore in the same, but I have two requirements. And he said, my requirements are, one is it will be like any class of Mercedes, which means whether it is an S class or a C class, the quality will not be compromised. We are not going to compromise our Shova quality just because we want to do it in a lower price bracket. And the second thing he said that is that I am in business. So my profit margin has to be secured. So that's a huge challenge. You're not compromising in quality, you're not compromising on your profit margin, then how do you do it? So that took us all over the world. I went to all the countries in the world, and some of the countries like Finland. I would say, if you really want to see the quality precast, go and see in Finland. I mean, the level they have taken it, like what Amit was talking about, the future of India in precast, which is the graphic concrete and things like that, or the three-dimensional concrete. I mean, you go and see what and their usage of GFRC, it's mandatory, because I also believe GFRC is one material which is next to concrete in terms of durability. So I was really impressed that the kind of work they were doing. And Finland, the problem is they can work only for 6 months. So in 6 months, they have to get it right. That was a compulsion.
Mhm.
But then we also realized that what happens in Europe does not apply in India. We have to have a benchmark which is similar to the Indian conditions. And that is how we zeroed upon Singapore. Request to everybody in audience is, Singapore is one country we should emulate for precast just blindly. Please visit the Singapore Building Construction Authority website, BCA website. It's one of the most exhaustive and the best website on precast, the kind of training they do, the kind of work they do. And then keeping that Singapore model, because they have been doing residential construction for the last 40 years using precast. Almost 95% is done with precast. So keeping that in mind, Tripathi ji, we decided that we will do this 10 million square feet project. It is called Shobha Dreamakers. We were very clear that we will not end up making a car like Nano. Nano was a brilliant car, but sadly marketed. So we wanted to, showcase that we are making a quality, affordable product, because unfortunately the affordable word has been abused in our country. So we emphasize that right from the beginning that we will have a 3 day cycle time, because our customer base were the people who wanted to check in their homes early. We advertised well in advance that 200 homes will be delivered 20 months ahead of schedule. And then we created a world class facility. Almost 100 crore we spent. A beautiful world class precast setup was done with state of the art lever cranes, and you name it, anywhere from the world. And I strongly believe that if you raise your bar the way world does it, you get the best mileage of the technology. But then you have to do it the way world does it. Problem comes that sometimes we try to indigenize it, we try to take a shortcut, and then you lose the value. So that project came out so well that it has been taken into account in the business case study in the Harvard School. So I think that's a testimony to precast. Here we did even the basements in precast. Every element was done in precast. And that gave me the confidence that what precast can done in India, because we had these worries, whether we will get the skill set here, whether we'll get the right quality checks here, whether we will be able to match up to the world standards. And mind you, those days the codes were also silent. Fortunately, I was also involved with the NBCC 2016, where we try to bring in the codes from all over the world. And now also, as Hemant was mentioning, BIS is working aggressively, including Mr. Yogesh, myself, Amit. There are a lot of us who are in one of the committees of the BIS, where we are trying to bring the best practices in precast into Indian industry. But so the point I'm saying is, this all gave me the confidence that we can do what the world can do. And the second project was Provident Park Square, again 2,500 apartments with a state of the art precast. I'm very excited to tell that one project which we did recently was one airport surveillance radar system, which was to be done at the Bangalore airport. And they wanted to do this building. It is like an ATC tower, to be designed and executed in less than 6 months' time.
Okay.
And precast was the only solution. And we did it beautifully. So I am a strong believer of the fact that, as I said, that precast is in our DNA. We Indians know about precast. We just have to raise our benchmark and say that this is what we are going to do. And I think it can be done. So with these two high-end projects, which I was associated with, I think it has been demonstrated that any good world-class precast projects can be done in India. But yes, you have to be, like they say, there are only three P's in precast. One is planning, planning, and planning. You have to plan it well,
Absolutely.
have to get your
Yeah.
concrete right, you have to get the best of the plant and equipments, you have to raise your bar the way world does it. And I think it's all possible. It's absolutely possible. And I'm so happy to see people are talking about, like Mr. Anurag talks about Indian Railways, because I always used to wonder about Indian Railways, because Indian Railways follow their own specifications. So I'm so happy to see that inroad is being made into Indian Railways. So I think there is huge opportunity in India when it comes to precast. Shirke is doing a lot of work for the last 40 years. I mean, they have been
Yeah.
holding a precast flag for last so many years. So I think
Yes.
there are some very good examples in India which has to
Yeah.
be emulated. My advice to all the audience is only one simple advice. Whichever project you are involved with, start with a small element of precast. Why can't the staircase be done? All the staircase can be done in any project in precast.
Yeah. There is one question from audience to you, that what is the name of the project, Soba project you are mentioning?
The project which I did without plastering is Shobha Indraprastha, right behind Bangalore City Station. And Shobha Dreammakers is the project which was done 10 million square feet. Today, that project is in an autopilot mode. They are doing 1 million square feet every year.
Okay.
One of the point which you touched, Raj, was like reduction in the what do you call sizes, like what Mr. Anurag's company is doing. Like they are making the precast very sleek. So reduction in the quantity of the concrete. I think Japanese are showing the way how to reduce the sizes. And for the same section, our Indian designers are making big sections are there, and those sections are very small. Anurag, you can just tell something about that. You are reducing the sections a lot, I understand.
Yeah, I will share an example with you that as everybody knows that it is very difficult to work in Bombay area, which is very congested. You cannot do the work cost in situ. And if you at all do it, you cannot provide the quality. So near JNPT area, New Bombay side, in dedicated freight corridor, you need to construct retaining walls. Height of retaining wall is varying from 4 meter to 9 meters, which is very, very high. So Tata Projects is the main agency who is executing the work. So they requested us because the cost of retaining wall, which they quoted to dedicate freight corridor as a client, was very, very high because they have taken huge, very thick sections and very. So what we did is we designed this retaining wall up to 9 meter high with M50 concrete and very, very sleek cross section. And finally, Tata Projects has approved it. And our first wall of 4 meter high, this 9 meter high retaining wall will be in 3 pieces. And that will be, those pieces will be joined with couplers, that mechanical coupler, which Mr. Amit Bade also talking about.
Okay.
In LNT. So it will be transported to site in 3 pieces and then it will be joined.
Yeah.
So this is one example which I'm talking about, that if you look at the volumes, and if you look at the economy in sizes, definitely in long run, precast can be a cheaper solution.
Okay, so when you say that you have done the reduction in sizes, so have you followed some other codes like Tata Projects must have done the design as per Indian codes and they must have arrived at certain sections. So what actually you have done to reduce the section sizes? Like have you followed some other country codes or have you done some experimental type of designs or what type of thing was done by your side?
Yeah, it is very interesting story. In fact, it took almost 6 months to get it cleared. Although I was the MD of the same organization, but you know that railway is a very conservative organization, and our PMC were Japanese. We ultimately tried our best to reduce the reinforcement cover, but that was not allowed. And then we also tried to play with the in a particular cross section, the moment of resistance and the shear force. There is a fixed ratio is given in the IS code. We also try to convince, because in other countries that ratio is different, so that we can reduce the cross section in that particular where the joint is there. But that was also not allowed. But anyway, this time we have done it. That's why I am very much strongly feeling that in India, all our IS codes should take care of precast technology as a different separate technology, so that we can utilize the full advantages of precast.
Okay, and since this is a topic we have come up with of a retaining wall, there is a question from audience. Like they're asking whether we can adopt pre-stressed precast method in retaining wall construction to prevent landslide failures.
No, certainly when we were searching for solutions for the retaining wall, I found that these kind of solutions are also available where we can further reduce the cross section and we can provide like counterfort retaining wall. There we can do the pre-stressing also, because ultimately it takes care of the tension in the member. So certainly it is there and technology is available.
Okay, Mr. Kajale, I just wanted to ask you about your views on the building information modeling. Like, what do you feel? What is the future of building information modeling in precast projects? Like, how do you follow that, and what do you see like future of building information modeling in your projects?
Yeah, before coming to building information modeling, I would just like to clarify to everyone. One question was raised, and we discussed this. That is there possibility of reducing the concrete sections just by using precast?
Yeah.
See, one thing, precast is what? Basically, it's the same structural design concept applies to precast construction as well. Precast is basically casting off-site and then installing at site. So as far as sectional reduction is concerned, it all depends on whether the designer is able to select some alternate load path or some structural design system by which he can optimize the section. Per se, the concrete requirement, if the same set of designing is done, it would remain same. As long as the reduction is possible only if we switch over to high grade of concrete or there is some other advanced structural systems, the load transfer systems are adopted. As far as fire resistance is concerned, there are a set of norms which have been stipulated in Indian standard. So one may not be able to go beyond that sectional sizes, no matter what grade of concrete is used. So that's the misconception that precast will be able to reduce the sectional sizes.
Okay.
If some innovative design systems are adopted, the load path is decided accordingly, then yes, it's very much possible. That's one part. As far as building information modeling is concerned, precast is the only industry rather in construction which can be very well get adapted to beam techniques. Currently, this is our third project, mass housing project, on which we are implementing beam, and the success story is project by project. We are actually achieving a lot of optimization by switching over to beam. So it starts right from planning, architectural planning, then services, then structural designing, and then connecting it to production processes as well as stacking, logistic in transportation, and then finally to building site erection. So beam has tremendous scope in the precast construction industry. The only thing is that since it's a mass housing project, it has different set of parameters which need to be considered as far as BIM modeling is concerned. So that's the only difference. It's not a typical one particular structure which gets constructed and then we start monitoring on a BIM platform. So same type of buildings are in numbers and the work happens at different floors. So that kind of setup needs to be integrated properly in the beam modeling. That's the biggest challenge. Now the industry and the experts are actually learning how to integrate that particular thing. So beam definitely has tremendous scope as far as precast industry is concerned.
Okay.
Yogesh sir, one question to you from my side.
Yeah.
Since your company is the one from last so many years, you are into mass housing and other precast constructions, and you are the pioneers, which I know.
Yeah.
And you have been doing so big projects like DDA's project and government projects and so large projects. So what has been we say in precast that we reduce the maintenance cost and other things. So what has been your experience about this last so many years in the precast buildings? Are we really saving money on the maintenance cost and acceptability of the people? And how do you see this precast as a private developers who will be getting into this business?
See, as far as maintenance cost is concerned, yes, we started way back in 1972. There were certain issues because the industry itself was new. It was not completely dense cement concrete elements which we used to use in those days about 40 years ago. So there were different set of challenges and different issues. In last 15 years, the precast industry, even with us, we have changed from lightweight cellular concrete as far as structural members are concerned to dense cement concrete. The maintenance cost on the completed buildings, even in case of residential mass housing scheme, I'm talking of mass housing scheme,
Yes, sir.
it has reduced drastically. Because if you compare the projects which were completed about 10 years ago with any other conventional system and the projects which were completed during the same period with precast construction system, then there are very few issues in respect of maintenance, regular maintenance of the building. In certain cases, the tendency of Indian residents are basically they try to renovate the construction, they try to change something inside the flat, and then the issue starts. Say, for example, if the toilet, bathroom, and WCs are converted into one single toilet, then there would be issues in changing the plumbing lines, then waterproofing issues. So, if those are well taken care of, no changes are permitted or it is limited to certain extent, then the maintenance cost on precast construction is almost nil. That
Okay.
is one thing. The second question which you mentioned was regarding.
This was for this one, like since livability and other thing, how had been the experience of the people who have been staying in those type of houses? Because some people, the comfort level which people say, sometimes I get questions like, since it is total concrete building or so, they will not be so people are having a lot of apprehensions of getting into the small houses and other things like. Acceptability of these type of precast buildings.
See, the precast houses are not a small houses. It all depends what clients require.
Okay.
So small is basically, say for example, if 25 square meter houses are asked to be constructed, naturally 25 square meter would be a small dwelling unit. And initially, whosoever occupies that particular flat, within a year or so, his requirement changes. So he may start feeling that it's a small house, but that small house would remain small even if it is constructed in cast in situ or any other construction
Okay.
method. So
Yeah.
precast doesn't have that kind of thing, that precast is only suitable for small houses and not for big houses.
Because I
As
read
far
in
as
papers, that people are not going and occupying those houses and other thing. All those type of questions do come in. And
yeah,
somebody
but
asked me why people are not going and living in those houses. Is
those,
there any
those,
safety issue? Is there any other issue? So I have to keep telling to the people, no, it is quite good. So that's I just wanted to hear from
no,
you
no, the
what
reason
feedback you
the,
get.
the reason behind that is the infrastructure, allied infrastructure, which is required to be created in and
Okay.
around the mass housing scheme. If that is not constructed, if that is not developed, then no matter whatever is the method of construction, the houses will remain unoccupied.
Okay. Okay.
So that's a different thing.
I
As
think.
far as comfort level is concerned, yes, in hot and arid zone, we have to be very choosy in selecting which walls are to be converted into concrete, which walls would require insulation. If those things are well taken care of, then the precast houses are as comfortable as any other houses. So
Thank you.
it's not related with the type of construction. It is basically related with the designs how we are going to tackle
Implement.
for
Okay.
that. Yeah.
Okay.
Thank you, sir. Thank you very
Yeah,
much.
I think Mr. Hemant has come back. So, Mr. Hemant, there was a question to you about usage of the sensors in precast elements, like how they can help in deciding the stripping time of a precast element. Say, if we have to strip a wall panel and we have to ensure that we are getting at least say 18 MPa or 15 MPa or 20 MPa. So can we monitor that using the sensors in wall panel, and how many sensors are required typically to monitor those things?
Yes, a very good question. To better answer your question, I'll put it in this perspective. These sensors are based on a rational technique called as maturity sensing, which actually captures the heat of hydration, the energy, and correlates the energy of the fresh crate to its strength, many types of strength for that matter, not only compressive strength, and also some other aspects such as setting times of concrete. Incompatibility issues can be easily detected, and also batch variations in concrete can be detected. Along with that, as Raj sir had said about steam curing regimes, steam curing regimes can also be controlled and resources can be optimized. With that, we come to the point where how many sensors to put in, where to put in, how to put in. All these guidelines are available, and the industry standard is that you'll require one sensor typically for around 15 to 30 meter cube of concrete. So that's a kind of a golden rule, but there are about 7 different rules, structural, non-structural rules that we have to follow to exactly decide the number of sensors and where to exactly put them and how to monitor them. So it depends on the project to project basis. If you can allow me, I can show you some case studies in which this has been done recently. Even today, we tested some sensors at Indo Global Precast in Wagholi, Pune. L&T has been using our meters. So if I can present some pictorial details so that the audience will know what these sensors look like, these meters look like, and how they are used in construction, especially precasting.
You
Do
can
I
share
have the
your
privilege?
yes, you can share your screen and quickly go through that so that everybody
Okay.
understands it thoroughly.
Yes, the first slide is about our panels.
Yeah.
So the advancement and the going way forward, one of these, the precast industry revolves around materials, construction systems, logistics, competent workforce is not available, and hence we need supporting systems. So in precasting, we have pre-stressed and non-pre-stressed structural and non-structural elements. For that, these are some avenues where us researchers and academicians are developing some new generation concrete, which we see that future will tend to use in their not only precasting work, but also general traditional build spaces. Self-sensing concrete, carbon-infused concrete, recycled concrete, self-cure concrete, biocrete, middleweight concrete, and smart concrete with structural health monitoring embedded inside. Self-sensing concrete also can function as a reversible sensing concrete and perform the function of not only maturity meters, but also structural health monitoring sensors. With that background, I come to the part where concrete maturity meter systems come in picture. We have integrated in this patented product that we manufacture in India for the first time, data science industry 4.0. Concrete maturity meter is part of industry 4.0 system, and it is cloud connected, and we have inbuilt artificial intelligence protocols to automatically calculate the real time strength of concrete and other performance characteristics. So let's see what is this maturity meter. In the picture you can see, so here's the maturity meter that we have indigenously developed for the first time in India, and it is affordable. It comes with 4 sensors. These are the normal digital sensors that you need to install in the fresh crate before concreting, and this is the only non-destructive test in the world that continuously monitors the strength and performance characteristic of from fresh crete to hardened concrete. And these sensors are reusable, and these meters are reusable, so you can use it multiple times and multiple configurations and multiple projects. So our motto is concreting with confidence. How to bring confidence in concreting through this data and the loss or reduction in human intervention. So this is the meter in detail. You can see reusable sensors, reliable and tested on field. Currently, several people in precast engineers are using this technology in India. Also, we are exporting these meters abroad for the first time in India as well. How it
Great.
works is based on maturity technique, which is pre-established, and IS 456 and IRC 112 does allow us to use the maturity method and the meters in our concreting works as an NDT method to ensure a quality concrete. This is how it is used. We have tested it in labs, research institutes, precast plants, on-site field, RMC plants and cement plants in India, especially in Pune, and found it very reliable. Most importantly, this technology is available pan-India, affordable, and the know-how is known now. And we have made these meters easily accessible to our end users. We call it a system because it consists of electronics as well as software and cloud computation as well. I'll present to you some key aspects here quickly and move on to the main application case studies.
I
So
think
that we can.
I think this much should be sufficient, and people can
Okay.
contact further for more details.
Sure.
I think this should
Certainly.
be
I'll
okay.
stop here. Thank you
Yeah,
for your
please.
time.
Thank you,
Yeah.
Hemant, for presenting this.
I think there is one question from audience to
Yes.
Mr. Raj Pillai. Have you faced seepage or leakage issues in your journey with Shobha and Starworth, since it's a residential project, if yes, what remedies did you take later to correct it or avoid it?
This question brings smile on my face because
Yeah.
I would have answered this question at least 1 million times.
Yes, actually, this is a very common question, so I just picked it up.
But there is no harm in it asking
Yeah.
this question because any new technology, there would be apprehension. There would be some reservations, and especially when it comes to high-end residential projects where a lot of money and reputation is at stake. So for any builder, he or she cannot afford any kind of seepage or leakage and things like that. So I'll I will say that the kind of the technology which is available today, definitely any kind of leakage in the joints is 100% ruled out. Now, I would say this with a caveat. The caveat or the precaution which has to be taken is that, see, when we talk about precast, one of the reason why precast has been a slow mover in the residential segment, because when you take the infrastructure segment, precast has been very popular. We have been doing all our bridges and infrastructure projects for decades and decades with precast. In the residential segment, what happens is that the quality of the elements which you make, because these elements are very small, you are making few meters of elements, and if you are doing a room size slab, the size of the slab will be only few meters. So the quality of the element plays a very, very vital role. Now, when I say quality of the element, one of the things I would say is the tolerance and the size of the element. So your tolerance has to be what the world follows, which is in the range of plus minus 5 mm. Now, if you have to get an element of plus minus 5 mm, your beds, your tables, your molds have to be very, very well done. You cannot afford to have tables, where you are not getting the elements or the molds with this kind of a tolerance. So the precaution starts from there. Then comes to another important aspect of precast, which is the erection. When you are erecting these joints and grout or any of the binding material, even SDC is used. If you are using these material, which are, what has been designed, it cannot exceed that. So the point I'm saying is if your material tolerance goes offside, then you will be putting more binding material than what is required. Thirdly, your detailing of the joints. The detailing of the joint is very, very critical. So the designer, if he or she has taken the profile of the joint, whether it is a vertical joint or a horizontal joint, and if you are using the accessories which are world class, whether it is the loop boxes or any other connecting material, I think if these precautions are taken, definitely there is no question of any leakage in the joint. Now, there could be cases of unsuccessful precast projects also in India. So let's not say that everything has been good in India as far as precast is concerned, especially in the residential segment. So there have been cases where we had not so successful stories, and in some of those cases, the seepage has been more prominent than the leakage, and the seepage could be because of either your shrinkage, cracks, or some other issues. So, in nutshell, I would say if your selection of plant and equipment is right, if your practices are what how the world see, let's take the code away for a while. I mean, code is just an internal guideline which tells you what has to be done, but I think we have to go beyond the code. We have to see, as I keep saying, that if you want to get the best advantage of a technology, you have to do it how the world does it. You have to benchmark against how the world does it. And I always give the example of Singapore. We should always blindly follow what they do, whether they do in their mass housing or whether they do in their high-end residential project. So if you benchmark yourself with respect to selection of equipment, if you benchmark yourself with respect to the transportation and the erection of the elements, how you connect the joints, how you design the joints, definitely there is not even 0.0001% there could be a cases of any joints or any leakage or cracks. By the way, the Showa Dreamakers project which I did, and it's almost I also have a flat there, and I took this flat only for the purpose to demonstrate that I believe in what I do, and this flat I am having for the last 6 years, and not even a single drop of water has entered anywhere. So I think what more proof you want?
I think, Raj, you are right that the devil is there in detailing, especially on the joints detailing and other things. So if every aspect is being taken care, and also one thing I differ from you is blindly following. See, in India, there are climate changes everywhere. Like if you say it is Singapore climate, you'll find more or less in Bangalore and other places. But we have to also see a lot of how the climates is behaving, especially in Kashmir and all. It will be different. Delhi, it will be different. Delhi, in a day you will get 40-degree temperature also and 10-degree temperature also in night. So that type of also differences are there. So we have to also, as a engineer, we have to take into consideration a lot of those factors while deciding our jointing material. So we cannot follow blindly Europe because European conditions are different. But yes, certainly a common sense has to be applied everywhere, for which we civil engineers are famous. Where we have to be more on common sense, and we have to see the why those type of technologies are being used, what material is being used. We must get into detail. So my takeaway in this will be to go into details of what is being used and question every aspect. Then it will come out the result will be in a good way. Thank you. Thank you very much.
Yeah.
No, I would take another 1 minute, Mr. Tripathi, because this I am saying out of my experience when we started the journey of precast.
Right, sir.
If you start any technology, it always helps you if you benchmark something, and then you don't try to reinvent the wheel. You try to do what somebody has been doing successfully for years. Enough data is available, and then you improvise it to your suitable conditions. So this is precisely the reason, after going to Europe, after going to US, everywhere, Scandinavian countries, traveling all those parts of the world, seeing how they do the construction, I felt that for the Indian conditions, especially from the user's point of view, like if you see the southeastern countries, we all have a tendency to mop the floors, which you don't do
Yeah.
in. So, and the torrential rains, like for example in Singapore, the kind of the flash rains you get in 30 minutes, it looks like that the city will be flooded. So I think if you take all those into account, my advice is that it is better to benchmark, and that is where I keep saying about BCA, the Building Construction Authority, that it is better to benchmark against somebody who has done that for the last 40 years. Now, yes, you are right, our climatic conditions are different. You may need double wall at some part of the country, which you may not need in some other parts of the country because of the delta in the temperature. But as far as the construction practices is concerned, I repeat, the construction practices are concerned, I think BCA is a very, very good document to refer to. And I'm sure the Indian brain is very intelligent. Over a period of time, we will evolve. And this is the crux of my journey. In the beginning, if we benchmark something like Singapore, it always helps.
Yeah, I've gone through the document. It is very exhaustive and very well written. I fully agree with you, Raj, in that case.
Yeah. And in continuation, there is one question from Dr. Shashank. He is asking what are the barriers for prefabricated structure in small scale construction? Why it is not following normal RMC type model or just like manufacturing industry model?
Yeah, I think that's a good question Dr. Shashank has asked. I think the problem, the challenge I see for the propagation or the penetration of the precast or the car or the off-site construction in India would be, I think he has asked that question in a different way, is about the scale of the construction. Incidentally, the precast construction involves captive investment. You need to have captive investment in your beds, in your molds. You need to have captive investment in your cranes, which are, because these cranes have to lift weight from 5 to 10 tons, typically at, let's say, 50 meters or 55-meter jib length. And these cranes are expensive. You got to have trailers. So keeping all this in mind, precast to happen in small projects or small cities or B tier and C tier cities would be a challenge, because unless, I mean, to have a model where, like a ready mix concrete, where you have a commercial ready mix concrete supplier across the country, that would go a long way in India in case of precast, because uh, the kind of the volumes which is required to set up a unit like this to do precast is a challenge. So my take on this would be, initially India will have its journey, and most importantly, the logistic plays a very important role in precast, in terms of cost and also in terms of operational efficiency to the precaster. That means if the crane is not able to lift certain number of elements in a day, the whole business model will not work. So keeping all this in mind, Dr. Shashank, I think my take is India's journey of precast would begin with, in two folds. First fold would be, it will be site-based captive precast plants like the Shobha Dreammakers I talked about, or large residential projects like what Shirke does or L&T is doing, where you have that kind of a volume, 1 million square feet, 2 million square feet kind of a thing over a period of time, and then it justifies the cost, and you will have a precast set up over there. The second thing which would take precast forward in India to begin with, definitely it will be a different story in next 5 years to 10 years time. I'm talking to begin with. To begin with, the second set of story would be the hybrid construction, wherein you will have a combination of precast elements along with the conventional system. But this would require a lot of effort from the structural engineers, from architects. All of them have to come together and arrive at a consensus that, so as to do the project fast, so as to reduce the labor dependency, let us do something which is off-site. Like I gave the example of no plastering. So I think these are the innovative methods which has to come in before we do actually full-fledged 100% precast. So I think that answers your question, I believe.
Yeah.
Yeah, I think there is one more question from audience to Mr. Kajale. This is related to how are large precast companies like BG Shirke and L&T taking up training of workforce for precast erections?
Yeah, that's the biggest challenge for the industry of our scale. Such skilled laborers are not available, the erectors are not available. So we have no choice than starting our own training school.
Okay.
So this is how we are tackling this particular problem. We devise our own training curriculum for erectors, for supervisors, for foremen, and we train them. The course varies from 6 weeks to 6 months time, and it's not only the theoretical training but the practical in-plant training as well. See, majority what we all are talking about, how it is manufactured, how the jointing is done. The success of precast construction lies in workmanship. Whether that skill set is available, no matter how best is the precast element, how best the precast element is manufactured, if it is not integrated properly into the final structure, the performance would be at stake. So workmanship is very important. it's not only the manufacturing of the elements, it's not only about selecting the molds, the techniques of manufacturing, the process of manufacturing, what grade of concrete is being used in the production of the precast element, but the success really lies on how intelligently and how correctly the elements are integrated into the final structure. So there plays what should be the construction tolerances. The construction tolerances comes in manufacturing tolerances as well as erection tolerances. And then whether the available skill set are able to fit those elements, assemble those elements within that construction tolerance or not. And that's the reason why three-dimensional precast elements are being thought of. The reason behind that is to reduce the number of joints. But it has another challenges. The weight of element, then the volume. The elements are required to be stacked on in the yard. So huge space would be required. So that is another set of challenge.
Okay. So how do you feel like if we have to follow the Singapore model of PPVC, where are we and how much time we actually need to graduate to that level? What is your take on that?
See, we started about 40 years ago as far as Shirkes are concerned. So
Yeah.
when we started, during those days, the tower cranes were required to be imported. And
Yeah.
to import the construction equipment or machinery, the foreign currency is required to be earned first. So it was
Okay.
almost impossible to import any construction equipment and machinery. So we, within our organization, we had no choice but to start manufacturing of even tower cranes. So that was a passion what Mr. Baburao Shirke actually lived with.
Yeah.
Today, in today's scenario, everything is available. The economy is open economy now. Anything can be imported. So that's not the issue. In India, it will take not less than 10 to 15 years to switch over to volumetric construction for
Mhm.
mass housing, because we have very limited space where the volumes are there. In all those urban areas, the availability of the land and the space is very little. So to transport that volumetric elements far away, it will have a huge cost. Then whether do we have that kind of turning radius for the infrastructure available within the urban cities where the projects are being taken up, that's another challenge. So to me, at least for next 7 8 years, 2D construction and little bit of 3D volumetric elements is the only way forward for taking the precast industry to accept future challenges. So that is what is at least I foresee that particular thing.
Yeah, you mean to say like some selective elements like
Yeah, yeah, yeah.
bathroom pods or kitchen pods and then
Even bathroom
connecting.
pots, see, even bathroom pots has the weight to the tune of something around 15 20 ton, depending on the size of toilet and size of bathroom. So lift elevator shafts, that is very much possible. The duct shaft, if the planning is done intelligently, the duct shafts can be converted into 3D pod elements. So selectively, see, precasting is not only how it is being manufactured. The first and foremost thing is how the buildings are required to be planned. What kind of standardization within the project we can achieve, how much repeatability we can achieve. So lot many things depends on planning, and then the planning engineer has to have real time experience how the things are manufactured, how the things are handled, how they are assembled. And giving due respect to all these three aspects, the planner, the designer should arrive at the solution for a particular project. Then only the project can become a success story.
Very well said, sir. Very well said.
Are there any further questions, or should we summarize like what Mr. Kajale and Mr. Raj Pillai just now said, that this could be like sort of progressive elaboration type of thing that we will get to see in case of precasting in Indian context? Like slowly we have to see how the infrastructure availability is there and how the crane availability and how the pricing goes, and then we have to graduate to the next step of precasting. So Mr. Raj Pillai, would you like to add something on this, like the way you see precast projects improvements happening in India?
Yeah, I would just like to extend what Mr. Yogesh was saying. You see, though I keep talking about Singapore model, but Singapore, we should understand their journey has been there for the last 40 years, and
Yes.
it was done with a mandate by the government. There is no option.
Yes.
You have to follow the government mandate, and by virtue of that, they have progressed very well. So when I say Singapore model, I don't mean that we should start doing the volumetric construction tomorrow. Because when it comes to precast in India, in my view, we are still a baby trying to crawl. We are not even walking. And Singapore, they are running. So we are far, far behind them, what
Yeah.
they are doing actually. So we have to be very careful, what we want to take from that model. There is another aspect in precast which Mr. Yogesh was mentioning. See, in case of Singapore, they have what is called as a DFA, that is designed for manufactured assembly. So there, every architect and every structural engineer, when they plan a building, they have to plan it under DFMA, which is not the case in India. The challenge in India is the architect will design one way, the structural guy will design another way, and then the advocates of precast like me and others will come in, and then the struggle starts. So we
Hmm.
don't work as a cohesive team when it comes to construction industry to take this whole technology forward. So there is a lot of gap between where Singapore is and where we are. And my take and advice on the way forward in India is, when we started the panel discussion, I saw some 108 attendees. So my request to all the 80 plus attendees is that, we are the people who are going to make it. Nobody else is coming from anywhere to make precast happen in this country. And why don't we take a small step, that whichever project you are associated with, as I use the word, the offsite construction, can we start doing one element at least, which is not a big deal. As I said, the staircase can be converted in all the projects to precast without any great difficulty. So let us take this baby step forward. See, the thing is, we have to demonstrate in the benefit of the industry, in the benefit of construction, and trust me, once it starts moving forward and people start seeing benefit, the internal and external resistance, the internal is, you know as I said, the different aspects of civil engineering, that is the architects, the structural consultants, the PMCs, things like that. And then comes the codal provision and thing. I mean, the moment we start having more success stories in small form, big form, or in 100% precast, I think things will start changing. So my request to all the attendees is that, you know it's in place of having all the doubts in mind, let us take a small step, that from tomorrow I'm going to use one element at my site and see how the learning curve would be. Because believe me, and I am saying it with a lot of conviction, that the day is not very far when we will be forced to do it, not by choice, by compulsion. Because the way India is going, the worry is whether we'll be doing it or the Chinese companies will be doing it in India. So might well we do it in India and get ourselves prepared.
Yeah.
Sir, very well said, Raj. Some things have to be done in precast so the baby steps are done and so that we are also able to walk. Because, see, so much of government initiatives are there, especially in the infrastructure side also, apart from the housing. Like I see in Uttar Pradesh, there are a lot of water mission is there in which a lot of overhead tanks and other things are there which have to be built in such a large scale. So mega projects are there where people are struggling with how to do it in precast, especially precast tanks, overhead tanks. And I tell you, some of the steps are, we have been trying to push this precast there. But yes, we are close to it. But if government push the things that yes, it has to be done in the offsite construction, because earlier also it is said that it will become a essential practice. It will be not a choice. It has to be done because it will be the need, because time is not time is the essence. So like public sector infra also should be forced, yes, that it should be done in precast. I think that should be the one of thing which should be pushed up.
Yes. So finally, what we can summarize, I think we are almost done on time.
Right.
So we can summarize it the way like looking at all these environmental constraints, we can say, like the infrastructure availability, like the cost of cranes, the cost of project and those things. So considering those factors, we can start doing some sort of hybrid type of precasting and then maybe aspire to go for 100% precast rather than directly switching over to 100% precast, looking at the different constraints maybe on the infrastructure front and the crane fronts. Yes, so I think we are good to sum up the panel discussion on this note.
Thank you, Dhananjay sir, for moderating the entire session, and thank you to all the panelists. I would now request Prasad Savikari sir, our secretary for ICI Pune Center, to propose vote of thanks. Prasad sir, over to you.
Thanks a lot, Sujata. Thanks a lot to all the speakers here. They have done a wonderful job. This panel discussion has was one of the wonderful, most enlightening session I have listened to in precast in many days. I'm thankful for being all these people taking out time from very busy schedule of theirs. In fact, Amit was not keeping well and still he managed to give the presentation, right, Dhananjay? He was not
Yes,
really
yes.
well and
Yeah.
still managed to come here. We wanted to have Yogesh Kajale earlier, but he also managed to come here. Thanks a lot for that. We'll be certainly taking this forward. Perhaps what I would like to have is we ICI Pune Center would be arranging these kind of discussions related to precast again in future panel discussions, and I would love if some of these speakers would like to join us, if they can take out time and join us further for our panel discussions also. I would like to thank Sucheta for her help. I would like to thank Usha Devi who has been here. And I also remember, I mean, the technical committee consisted of lot of people and who have been meeting for almost more than 4 months, right? Dhananjay, we have been meeting for 4 months for almost every Monday at 2 p.m. exactly. And these efforts must be lauded for from the technical team. Maybe Dhananjay mention all those people who are on the technical team. That's from my side.
Tripathi ji was there, then Ravindra was there, Mangesh was there. So plus Ram Babu was there. So everybody used to participate in this technical discussions and deciding the way forward for SEMCON 21.
Okay, so with this, I would like to conclude this SEMCON 2021 digital event and announcement for people that we have done physical event at College of Engineering Pune. Those 15 sessions recordings would be available and you will be getting an email about when those sessions would be available. Please try to go through these lectures, and if you have some questions, send it by email to us. We will be trying to send you the answers for those questions also. Thank you.
So thank you everyone for your time and support. So we are concluding the SEMCON 2021 digital event also, and further communications will be communicated on email. So thank you everyone. Thank you for all the
Thank
panelists.
you. Thank you very much.
Thank you.
Thank you.
Thank
Thank
you.
you.
Thank you very much. Thank you.
Thank you.